So last time we looked at plane sailing, and what is the plane sailing formula? Is basically departure divided by dlat is equal to tan cos. Then we were using mean latitude. I explained about the difference between the mean latitude and the middle latitude. So today, let's see whether we can. So here, the difference here, you can see I'm was catching up from the last session. Uh, you can see AB, the vessel is moving from A to D. Okay, then A in the D to the vessel again within 600 nautical miles. A D distance uh, 600 nautical miles. So again, the plane sailing use we can use plane sailing because the distance between A and D is less than 600 miles. You can use plane sailing. The reason is that between A to D, there is a slight curvature, right? Body curvature. A departure port D arrival port delta. A alpha departure port D delta arrival port So the departure port latitude is going to be AB, and arrival port latitude is going to be CD, and the mean lat is basically the arithmetic addition of these two latitudes and the mean value between these two latitudes, which will be represented by simple A and B. So that is the mean latitude. But as you all know, the AB distance does not represent the actual distance, east-west distance, which we call departure. The simple A and B mean latitude does not represent the actual departure. Departure කියන්නේ මොකද්ද? East west direction එකට nautical miles වලින් තියෙන දුර. ඒක simple A and B වලින් represent වෙන්නේ නැහැ. ඒක නිසා මේක ඇත්තම between A and D, capital A and capital D, the actual departure is represented by simple C and simple D, which we call the middle latitude. So in order to find the middle latitude, you can see the formula. It's very complicated formula, right? Mathematically complicated and long. So we are not using that one. Instead, we are using simple arithmetic mean latitude. So within 600 nautical miles, this CD and simple AB is very close to each other. So we can use it without issue for plane sailing. But when it comes to longer distance, more than 600 nautical miles, we cannot use this method. It's not possible, right? So that is why we are using a different method other than this. So there are different types of sailing types, but we are going to talk about a couple of sailing types only: parallel sailing, plain sailing, and the Mercator sailing. Weight circle sailing is a different sailing type. We will talk about that one later. So let's now look at, let's see how we can see the difference between these two. I will just do a quick uh, calculation so that you can see the difference between this simple C, D and simple A and B. This, what I am doing now, you don't need to know, right? You basically, this is for your understanding only. You don't have to prove this, or you don't have to, this will not be coming into exam, and this is a bit complicated. දැන් මම මේ කරන්න යන්නේ middle latitude එක සහ mean latitude එක අතර වෙනස පෙන්වන්න යන්නේ. මේක ඔයගලන්ට මේ ඔයගලන්ගේ exam එකටවත් ඔයගලන්ගේ මම හිතන්නේ syllabus එකෙත් නැද්ද කොහෙද. But as a navigator, you should understand navigation. ඔයගලන්ගේ syllabus එක නෙමෙයිනේ navigation කියන්නේ. So you should have a better understanding what you're doing as a navigator. So මේක මේ that's why I told you from in the very first day that I will be going beyond STCW to explain certain things. Right. So let me take something. Okay. So let's see. Let's take two waypoints. Sorry, 1 minute. So let's take two waypoints. Doing some coding and I forgot to close that. Okay, okay. So you are moving from A to D. Okay. So let's take some distance. Let's say you are moving from 30 degrees north latitude to 34 degrees north latitude. Okay. What I basically gave you is the latitudes. So you are moving from A to D, 30 degrees north to 30 degrees, 34 degrees north. And let's look at the mean latitude. So here you can see the mean latitude is very simple. In latitude is 32 degrees. So can you see that? Are we clear? Are we clear, guys?
Yes, sir, clear.
Okay. So mean latitude is 30, but let's calculate the middle latitude. So in order to calculate the middle latitude, I have to take this formula, right? You can see the formula, it's very long. So I will take it to the other side so that I can write it here. What is sec? Sec means what? So here the latitude is the middle latitude. Okay. Let me write it like that. I just put empty line. Okay. So 7915 decimal 7045 divided by, what is the DLAT between these two? 2 log 10 tan 45 degrees plus um, latitude of D divided by 2 minus log tan 45 degrees latitude A divided by 2. Log 10 tan 45 degrees latitude A divided by 2. So you can also do the calculation with me. Um, so what is sec? Sec means what? I'm sure you have done mathematics. If you are doing your class 3, there is a mathematics and applied science subject as well. So what is sec in trigonometry?
එකයට කොස්
Yeah, 1 divided by cos. So I can write it like 1 divided by cos md lat, right? 79157045. In this case, how much is d lat? 4 degrees. 4 degrees into 6. 6. How much, guys? 4 degrees into 60. Isn't it?
4 degrees north.
Sorry.
4 degrees north.
No, d lat is always show in minutes. So how many minutes now? 4 degrees into 60, right?
240 minutes.
Yeah, you guys have to respond, okay? Otherwise, I don't know whether you are listening or not. So I'll just put LG here instead of writing everything. Tan 45 plus latitude D is 34 divided by 2 minus LG tan 45 latitude A is 30 divided by 2. Okay, so 1 divided by cos md left equals to, shall we calculate the tan value and the log inverse? Unfortunately, I don't have my scientific calculator, but anyway, let's see. Anyway, let's see. We can do it. If somebody can get the answer, please write the answer here. So tan 45 plus 34 divided by 2. Okay, somebody else is also. Plus 45, 60, tan 62 degrees each. You can also do the calculation with me and find out what is the middle latitude is until I do this one. 1.8807 minus 30. Point 73058. Can you all see what I'm writing? All right. Okay. So let's calculate these two. 1.8807. 508. So I'm getting so I will change the side so it will become cos MD lat, which is equals to 240 divided by 79157005 into 0.0357658. Just check whether I have done any arithmetic mistakes, which I normally do almost all the time. 7915 that 7005. I mean, if somebody can calculate the same thing what I'm calculating. Seven six five zero one two three five seven. Okay, so we are. So what I'm getting is 0.84772225. So cos inverse MD latitude equals cos inverse 0.84772225. Okay, so let's find out the cos inverse. 0.84772225. 84772225. So the answer what I'm getting is 32.035 degrees. Okay, so you can see here that is 32 degrees. Um, once you convert into degrees and minutes, so you have 0.35. So the answer is 32 degrees 21 minutes. Can you see that? Can you all see that? Yeah. So now you can see the middle latitude is the mean latitude. Previously, the mean latitude what we got was what we got was basically 32 degrees, but the middle latitude is 32 degrees 21 minutes, and mean latitude is 32. So can you see the difference? Even for a short distance, like 4 degrees, is not so much high, right? even for 4 degrees of DLAT, there is a difference of 21 minutes, right? So you can see the middle latitude, the mean latitude does not represent the middle latitude. The actual east-west distance. But for plain sailing, we are using it because for 600 nautical miles, this is negligible. But if you are sailing for 3,000 miles or 1,000 miles, for example, let's say you are coming from Australia to South Africa, for example, okay, you cannot use mean latitude in that case because the distance is so high, you are crossing ocean. So in that case, we need a different methodology to uh, calculate the course and distance. Because if you can remember, as a navigator, your most important calculation is what? Only basically two things. Number one is your course, and the number two is the distance. Number three is your position or the location where you are at any given time, right? So if you know these three, you are a good navigator, basically, right? So then now let's go to the before we go to the projection, before we go to the Mercator sailing, let's look at what what is Mercator in the first place, right? So there was an issue. Let me open up uh, 3D view. Can you all see this? Take this one. Okay, here you can see. Now let's assume you are moving from this point to this point. Okay, you're moving from this point to this point, right? Can you hear me, guys?
Yes, sir.
Okay, so I'll just go one line at a time. No, let me do it like this. So anyway, you are moving from this point. Okay, I'll draw a small circle here. This point to this point. Okay, but the problem is if I draw a great circle, the shortest distance between between these 2 points is the great circle distance. We already, I mean, in our last sessions, we have already seen that it is the shortest distance between 2 points. So if we do great circle sailing from here to here, it is the shortest distance. And if we can do great circle sailing, we can save the fuel, the time, and everything. It's very efficient. But unfortunately, if we do great circle sailing, the problem here will be when you draw a great circle between these 2 points, the great circle will be cutting all these meridians, isn't it? The great circle will cut all these meridians. But the problem is, when the great circle is cutting the meridians, they will not cut the meridians in the same angle. For example, if we take these two, okay, this is a great circle. Assume that you are moving from this point, okay, to this point. Now your course is going to be this. This is your course, isn't it? Guys, please respond.
Yes, sir.
This is your course from north, right? From north towards your right, because meridian is representing north. This is your course, and this is your next course. When the meridian, when the great circle is passing the meridian, the course represents this angle, right? I will go that one as well. So this is the other course. Right. Okay. Are we clear? So you can see all these are courses I can go, right? But the problem is, can you see this angle, right? If I measure this angle, let's try to measure it actually. Let's see how much it will be. 120.7 you can see in the bottom left hand corner. You can see 120.7. Okay, let's try to measure this one. Not exactly, okay. So it is 105 degrees, 110 degrees. Can you see? Can you see, guys? Okay,
Yes, sir.
if you
Yeah,
if you if we go here and let's try to measure it, it is 110 degrees, but since it is so close by, it will give you the same value, right? Try to measure it again. So 116 degrees this one. Um, and this one 120 degrees. So you can see the courses are along a red circle, the courses are not going to be same. Can you see that? Are we clear?
yes, sir.
So that because of that reason, now when you are sailing, I'm sure you have steered a ship. When you're steering a ship, the course will be given to you, right? You steer on 313 degrees or 0 to 8 degrees or something like this. The course will be given to you, and you are moving in that direction directly. But you can see if you move along a great circle, you have to always change your course. Can you see that? Can you identify? Are we clear on this? That you need to change the course continuously. Let's say you are moving from one waypoint to another waypoint, right? Along, so normally in the chart you can see one course is laid, let's say 070 degrees to this is one course, and even this course is cutting several meridians. All these angles are 070. But if I draw a great circle, if you saw it in the 3D view that the great circle does not cut each and every meridian in equal angles, so your course is changing. So this was an issue that you cannot do. I mean, you basically normally you can't. It's not easy to do great circle sailing on board a ship because the courses are changing. These days it will be okay because you have the XDs and everything, but GPS, XDs, and I mean all sorts of navigational electronic equipments are there, so you can basically do it. But those days that was not easy, right? So, for example, you have the magnetic compass only, you have to steer the vessel, so you cannot always stay in the course because you cannot find your position continuously. If you can remember on the very first day or in the second session, I was explaining that how the olden days mariners were using sextant to find out the position. So the morning position line by the third mate, second mate, and the chief mate. So then noontime position fixing, then correcting the course back again. So likewise, nowadays you have the GPS, you can correct your position easily, but those days it was not possible. So you need a constant course to steer. But if you are using great circle, you cannot do that. That is why this problem was an issue even in 1600s. So before the Mercator projection came in, so the answer for this question was the Mercator sailing. So before the Mercator projection came in, you can see. Can you see my screen, guys? The presentation.
Yes, sir.
Okay. So before there was different type of charts like photo charts in 13th and 15th century BC, 15th century, not BC. Uh, and I'm sure as navigator, Sri Lanka was, I mean, the Sri Lankan navigators were running ships for more than 3,000 years ago. Even our ships were there, as I explained in the first session. Right? I'm sure we must have used some kind of a charting system, but unfortunately, that technology is now. Uh, I mean, it's hidden and it's gone. It's vanished. So nobody knows how we have done navigation those days. But if you look at the global preserved systems, you can see in 13th and 15th century they were using something called photo charts. Then this is the Ptolemaic charts uh, by the Claudius Ptolemy in the 2nd century. That means almost like 1,800 years ago. But why I specifically put this Ptolemy? This is the Ptolemy's world map. Okay, this is the world map which was developed by Ptolemy, and specifically I just wanted to show you this map piece because this chart is because basically you can see Sri Lanka here. Can you see my cursor, guys? Can you see my cursor? Right here, you can see like a triangle. This is Sri Lanka. Where, I mean, those days the Romans and the Greeks were calling us Sri Lanka as Taprobane, right? Uh, so this is Sri Lanka. Even in Ptolemy's map, 1,800 years ago, we Sri Lankans or Sri Lanka was a maritime hub. You can see that because that is why specifically Ptolemy have mentioned that in his world map. And to the east you can see China, and to the west you can see Arabic Peninsula and the rest of the European countries. Even you can see Gibraltar, right? So this was 1,800 years old, okay, and we were in that map. Unfortunately, nowadays you know where we are, which I don't want to discuss in this forum. Uh, right, let's go to the next. So then this was a problem. Can we draw the earth so that a constant compass bearing becomes a straight line? Right? So that means when you're sailing, you must be able to sail along a constant compass bearing without changing the compass bearing like in a great circle sail. Right? So how to do that? The answer was given by this person. His name is Gerardus Mercator, right? Uh, but his actual name was Gerardus Kramer. But there was some mix-up between Latin and his name. So if you are interested in the history, you can go and find out more about Mercator. So he came up with the answer in 1569. He answered the question by this Mercator projection. So the he published his first Mercator chart, and the title was A New and Augmented Description of Earth Corrected for the Use of Navigation. So why he says corrected for the use of navigation is basically one course to steer between two waypoints. You don't have to change the courses, right? So the Mercator projection is said to be a cylindrical orthomorphic projection. What does it mean? It's like you can see the cylinder, right? I mean, when you project this earth into the cylinder, assume that you have a light bulb in the middle, in the center of the earth, and you switch on the light bulb, and you will see the meridians is getting projected into the cylinder. what will happen in the Earth, in the actual Earth, the meridians are converging in the poles and meeting each other. මොකද්ද මම මේ කිව්වේ meridians ටික ඇවිල්ලා අපේ පෘථිවියේදී north pole එකේ හෝ south pole එකේදී හම්බ වෙනවනේ meridians ටික. right? හැබැයි project කරාට පස්සේ Mercator projection එකේ project කරාට පස්සේ මේ සිලින්ඩර් එකේ වැටෙන ඉරි ටික හිතන්න මේ පෘථිවිය ඇතුලේ මැද්දේ ලයිට් බල්බ් එකක් දාලා තියෙනවා කියලා බල්බ් එක පත්තු කරාම මේක ප්‍රොජෙක්ට් වෙනවනේ. අර ෆිල්ම් හෝල් වල වගේ. so මේ ප්‍රොජෙක්ට් එක ගිහිල්ලා වැදුනම මේ meridians ටික තනි කෙලින් ඉරි වගේ පේනවා. and with equidistance. equidistance කියන්නේ මොකද්ද? distance ටික සමාන. right? ඊට පස්සේ මේ සිලින්ඩර් එක දිගහැරලා ෆ්ලැට් කරා නම් අපිට එනවා Mercator chart එක. ඕක තමයි වෙලා තියෙන්නේ. ඕක තමයි automorphic projection එක කියන්නේ. right? Are we clear? Are we clear, guys? Okay, so this is called Mercator projection, right? But the problem is when you project the Mercator, when you look at here, when you project the chart, right? There will be distortion in the land. Okay, but for a navigator, that is not our problem. අපිට ලෑන්ඩ් එක ඩිස්ටෝට් වුණා කියන අපිට ප්‍රශ්නයක් නැහැ. උදාහරණයකට ගන්නකො දැන් මේ නෝත් පෝල් එකට ළඟ තියෙන ලෑන්ඩ් එකක් මේ එතකොට මේ මෙයා දිගෑරියම ඔයගොල්ලන්ට පේනවා ඇති මෙතන මේ ස්ට්‍රෙච් වෙනවා ලෑන්ඩ් එක. ලෑන්ඩ් එක ලොකු වෙනවා. right? ලෑන්ඩ් එක ලොකු වෙලා එයාගේ actual size එක නෙමෙයි පෙන්නන්නේ නේද? ඊට වඩා ලොකු size එකක්. For example, now you know the Greenland is if you go to a Mercator, if you go to world map, you can see that the Greenland is bigger than Africa. But actually, the size of Greenland is smaller than Africa. Right? So, Greenland in the chart is bigger compared to Africa. The reason is because there is a distortion in the Mercator chart. There is a distortion in the land. Right? It gets stretched out. But for navigation, that's okay. We don't have issue with, we are not land surveyors, no? So we don't have issue with the distortion of the land. For our main problem is getting constant compass bearings to sail, or getting constant courses to sail. Right? That was our problem. So Mercator gave us a solution, but the distortion is there in Mercator chart. So there are two types of distortions. You can see that. First one is that you can see the meridians are getting parallel to each other, or in other words, longitudes are parallel to each other. In actual Earth, they are not parallel to each other. They are converging at the poles. So the next distortion is, you can see as you go towards northern latitudes, the distance between each latitude is increasing. So that is the second distortion. Can you see that, guys? Are we clear? Okay, distortion එකක් තියෙනවා. මම මේක සිංහලෙන් කියන distortion දෙකක් තියෙනවා. එකක් තමයි meridians ටික කෙලින් වුණාම ඔයගලට පේනවා ඇති මේ 80 degrees north එකට ගියොත් එහෙම 80 degrees north එක meridian දෙකම එහෙම නැහැ. මේ දෙන්න ලං වෙලා ඉන්නේ. මොකද poles වලට north pole and south pole යද්දි මේවා converge වෙනවා. right? දැන් මෙතන ඇදලා තියෙන්නේ. okay? There is a elasticity effect here. දැන් මෙයාව ඇදලා තියෙන්නේ, stretch කරලා තියෙන්නේ. stretch වුණාට පස්සේ මොකද වෙන්නේ? මේ දෙන්න අතර gap එකක් ඇදිලා එතන land එක තිබ්බොත් land එකත් stretch වෙනවා. right? So then that is the first distortion. The second distortion is that you can see between each and every 10 degrees, you can see the distance between the latitudes are increasing in the chart. Can you see that?
Yes.
Okay. The reason is now I will explain it again. The reason is now assume that you have a bulb in the center of the earth. Bulb will not be able to project north pole into the cylinder. කවදාක්වත් මේ north pole එක මේ අතුලේ තියෙන bulb එකකට බෑ north pole එක project කරන්න cylinder එකට. පේනවා නේද? එයා අනන්තයට යනවා. Okay. ඒකින්ද තමයි මේ උඩට යන්න යන්න මේ latitudes ටික ඈත් වෙන්නේ. Right. එතකොට 90 degrees latitude එකක් Mercator chart එක පෙන්වන්න බෑ. Okay. north pole එක යට Mercator chart එකේ පෙන්වන්න බෑ. ඒකට වෙනම chart වර්ගයක් තියෙනවා normal charts කියලා. මේක පෙන්වන්න බෑ Mercator chart එකේ. ඉතින් Mercator chart එක effective වෙන්නේ සාමාන්‍යයෙන් lower latitudes එක කියන්නේ 70 degrees north වලට වඩා පල්ලෙහා 75 degrees north වලට වගේ පල්ලෙහායින් තමයි මෙයා effective. මේවා අපිට පාවිච්චි කරන්න පුළුවන්. තව උඩට යන්න යන්න මෙයාගේ effectiveness එක එහෙම නැත්නම් මේ chart එක practically use කරන්න බැරි වෙනවා. Are we clear?
Yes, sir.
Okay, so then there are two types of distortions. So before we come to the, so this is the Mercator projection, then we'll come to meridional path scaling. අරගෙන ආවා meridional path scaling හේතුව ඉස්සරම අපි define කරමු meridional path scaling. The meridional path for any latitude is the length of a meridian between the equator and that latitude on a Mercator chart measured in units of longitude scale. That is to say, IE means, that is to say, the number of times 1 minute of longitude can be laid along a meridian between the equator and that latitude on a Mercator chart. Let me draw and show this to you what is meridional path means. Can you all see what I'm writing? Oh, my writing pad, can you see that? Okay. Now, this is what was happening. So, meridional paths. What are the definition? Again, I will show you the definition. The meridional path for any latitude is the length of a meridian between the equator and that latitude on a Mercator chart, measured in units of longitude scale. Okay. Then මෙතන අපි කඩාගමුක මේක කොටස් කීපයකට. So we'll divide this definition into couple of points. First one is the length of a meridian between the equator and that latitude. Length of a meridian between the equator and that latitude on a Mercator chart. So this needs to be a Mercator chart measured in units of longitude scale. So if we go back to, so what is the first thing? Right. So we are talking about, it is the distance between the equator and the latitude. So that is the first point. Second point, what are they saying? On a Mercator chart, this is on a Mercator chart, which has to be a Mercator chart. The third thing is, right, measured in longitude scale. Right. Can you all see what I'm writing, guys? Can you guys give me a minute because I'm having whole issue with my writing pad. Give me a minute until I um, close this and open up another application. Just give me a minute, okay? Hold on. Okay, can you all hear me?
Yes, sir.
All of you can hear me, right?
Yes, sir. Yes.
Okay, right. Can you see what I'm writing? Can see?
Yes, sir. Can see.
Okay, all right. So let's take the points. So the first point is it is the distance between equator, right, and the latitude. Second point is what? In a Mercator chart. Third point is what? Measured in longitude scale. Are we clear?
Yes, sir. Clear.
Okay, so this means what? This means, right, if you draw a Mercator chart, let's say I will draw a big, very big Mercator chart in the bottom line is the equator. That means 0 degrees north. Are we clear?
Yes, sir.
This is a Mercator chart. Okay. Then I will take the first longitude 1 degree east. This is 2 degree east. This is 3 degree east. This is 4 degree east. Now you can see I can divide this one into small pieces, which will be equal to 1 minute, isn't it?
Yes, sir.
I just divided the 60 degree because 1 degree is equals to 60 minutes. So 1 degree divided into 60 pieces, which will be each piece will be equal to 1 minute of longitude. Okay, are we clear?
Yes, sir. Clear.
Okay, right. Then what does this mean? Distance between the equator and latitude. Now I just wanted to draw at where the 10 degrees north is in this chart. So how to find it out, right? Where is it going to be here 10 degrees or is it going to be here 10 degrees? So this is a problem, right? Right? For example, let's say this is 2 centimeters. So after how many centimeters I can find 10 degrees in this chart? Did you understood my question?
No, sir. Can you please repeat it again?
Assume that this is a Mercator chart. Okay, this is a chart. This is a Mercator chart. Okay, this is a Mercator chart. Right? In this chart, 1 degree I have shown using 2 centimeters. chart එකේ දිගමැන්නම සෙන්ටිමීටර් 2යි 1 degree එක මම පෙන්නලා තියෙන්නේ. මේ හැම degree එකක්ම සෙන්ටිමීටර් 2 ගානේ distance එකකින් පෙන්නලා තියෙන්නේ. පැහැදිලිද?
Oh, sir.
Now the problem is I wanted to find out in this latitude scale, in this latitude side, where is 10 degrees north? 10 degrees north මේකේ කොහෙද එන්නේ කියලා. Okay. Is it coming at 5 centimeters, 10 centimeters, or 20 centimeters? We need to find out where it is. Did you understood?
Yes, sir.
Okay, that is where the meridional paths are coming in. According to the definition, it is the distance between equator and the latitude. So that means equator and 10 degrees north. It is the distance in a Mercator chart. Okay, this is a Mercator chart measured in longitude scale. That means what? Measured in longitude scale means this 1 minute. Now you have 1 minute here. We are going to measure if this is 2 centimeters. What is one? How many minutes will be? How many centimeters will be 1 minute? If this is 2 centimeters, 1 minute is going to be how much?
2.
2.
2 divide 60.
Yeah. So that is how much in centimeters? Or in 2 divided by 60 is how much? 0.33. No? So shall we convert it to millimeters? 2 centimeters is 20 millimeters. So how much? 1 minute will be equals to 0.33 millimeters, right? Isn't it?
Yes, sir.
තේරුණා නේද? Okay. Now let's look at the meridional part for 10 degrees. දැන් මේක meridional part කියන එක දීලා තියෙනවා table එකකින්. කොහෙද table එක තියෙන්නේ? Let me open up the table 1 minute. Give me a minute. Can you all see the table?
Yes, sir.
Okay. Where can you find this table? මේ table එක කොහෙද තියෙන්නේ?
Norris table එකේ.
මේක තියෙන්නේ Norris table එකේ. Yes. Norris nautical tables කියන පොතේ මේක ගන්න පුළුවන්. Page number, it depends on the version. This is starting from page number 94. So in the Norris table, you will find the meridional parts. Now let's go to 10 degrees. Here you can see 10 degrees. Can you see that? පේනවනේ 10 degrees. Can you guys see?
Yes, sir.
Okay, you can see here 10 degrees 0 minutes is 599.01. What is this 599.01? So let me go back to my, okay, so 599.01, right? What is this 599.01 means? From the longitude scale, right? How many? So let's say this is 2 centimeters, or if you take 1 minute in the what do you call it, in uh, minute scale. අපි මිනිත් ස්කේල් එක ගන්න ඉස්සෙල්ලා මම මිනිත් ස්කේල් එක පස්සේ එක්ස්ප්ලেইন කරන්නම්. මම මේ පාර්ට් එක පොඩ්ඩක් සිංහලෙන් කියන්නම්. ඔක පටලව ගන්න හින්දා මේ මොකද්ද මේ 599.01 කියන්නේ? මේක මෙරිඩියනල් පාර්ට් එක. හරිද? මොකද්ද මේ කියන්නේ? මෙන්න මේ දිග ගත්තොත් x කියලා. දැන් අපි 2 cm කියන එක ගත්තොත් x කියලා. x ඒවා 599.01 උඩින් තමයි 10 තියෙන්නේ. ඒ කියන්නේ මේ chart එක ගත්තොත් එහෙම මේ chart එකේ longitude scale එක 2 cm එක අපි ගත්තේ හින්දා 2 cm ඒවා 599.01 උඩින් තමයි 10 degrees north තියෙන්නේ. මේක තේරුණාද?
Yes, sir.
ඕකේ. මෙන්න මේක තමයි මෙකිඩියනල් පාත් කියලා කියන්නේ. මේක මීට වඩා ටිකක් සංකීර්ණයි, right? මම මේක සිංහලෙන් කිව්වේ එකයි. Anybody who cannot understand Sinhala, I'm not sure, I forgot to ask early. Anybody who cannot understand Sinhala? I hope everybody can understand. Only 20 guys are here today, so I don't think anybody is there who cannot understand Sinhala. All are good, right? Okay, right. So this 599.01 කියන එක ඒ කියන්නේ in simple, right? In very, very simple terms, if you take longitude scale as 1, so you have 599.01. If you go upwards along the latitude scale, you will find 10 degrees. So then you can create a Mercator chart. මේ සෙන්ටිමීටර් දෙක ගත්ත Mercator chart එක 1 degree එකකට අපිට සෙන්ටිමීටර් 10 degrees north හොයන්න නම් අපේ chart එක උස වෙන්න වෙනවා සෙන්ටිමීටර් දෙකේවා 599ක්. ඒ කියන්නේ how many? Almost 600. No, 600 into 1200 centimeters. ඒ කියන්නේ මීටර් 1.2ක් විතර chart එක ඉස්සෙන්න ඕනේ 10 degrees north mark එක ඒ chart එකේ පෙන්වන්න. Are we clear?
Yes, sir.
All right. Okay. So meridional paths in simple terms, you can see that what is the meridional path means, right? But අපි ගණන් හදන්න වෙච්ච in detail ගන්න අවශ්‍ය නැහැ. But chart construction එක in detail පොඩ්ඩක් දැනගන්න ඕනේ because you guys are working on the Mercator chart. So because of that, you should understand the construction of the chart in deeply because I think in your exam also they will be asking about meridional principles of navigation. They will ask, probably they will ask about what is a Mercator projection and what are meridional paths are. So likewise they will ask. So in order to find the meridional path in a spheroidal earth, right, this is the formula that needs to be used, right? So in a spheroidal earth, this formula, if you are good in mathematics and if you are good in computers, you can insert this formula into an Excel sheet, right? And you can easily find out the meridional part for this latitude. Okay, are we clear, guys?
Yes, sir.
Okay, but there is a small typing error. This L in your left hand side is the meridional part. Actually, it's not the latitude, because if you're going to find out if you're going to solve this formula with three L's and two L in one side and the other L in the left hand side, it will be a nightmare for you to solve this formula. So just forget about it. Forget about the mathematics. It's basically This is basically to find out the meridional path using a formula, and if you're good in computers, you can uh, insert this formula into Excel sheet and you can find out the meridional part. But there will be a very slight error, right? Uh, Compared to your nautical Norris table meridional paths. There will be a slight error, a decimal point error will be there, because why I'm telling you is I have done that one. So because of that, I know there is a small error, right? Because and also and there are different type of Norris nautical tables versions. Maybe you will find in certain Norris nautical tables, the meridional paths are different from the other table. In one or two decimals will be here and there will be a slight difference. Okay. ආපහු කියන්නම් nautical මොනවාද පොත් nautical books තියෙනවා Norris nautical books වර්ග කීපයක්ම තියෙනවා. ඒවල versions තියෙනවා. ඒ සමහර versions වල meridional part tables දෙකක් compare කරාම පොඩි වෙනසක් තියෙන්න පුළුවන්. දශම ස්ථාන ගානක වෙනසක් තියෙන්න පුළුවන්. ඒකින්ද කලබල වෙන්න දෙයක් නැහැ. ඔයගලන්ට මං හිතන්නේ එක්සෑම් එකේදී දෙන්නේ එකම જાතියෙන් nautical tables කියලා අපි හිතමු. But there will be a slight difference between book to book and also formula to book as well. Okay, ඒකින්ද ඔයගලන්ට දෙන meridional part එක use කරන්න. ඒකට හේතුවත් ඔයගලන්ට පේනවා ඇති මෙන්න මේ formula එක විසඳුවම තමයි ඒ උත්තර එන්නේ. ඉතින් ඒ උත්තර පොඩ්ඩක් එහාට මෙහාට දශම ස්ථාන ගානකින් ඔය වටේලා එද්දී එහෙම රවුන්ඩ් අප් කරගෙන එද්දී එහෙම පොඩ්ඩක් එහාට මෙහාට වෙන්න පුළුවන් පොතෙන් පොතට. Right. Next one. What are the advantages of Mercator projection? Rumb line. So what are rumb lines now? Rumb line is basically if I go back to the 3D view, can you all see the 3D view, guys?
Yes, sir.
Okay, rumb line කියන්නේ මොකද්ද? දැන් මේක වටේ මම Mercator sailing කරනවා නම් එකම if I draw the course with the same angle to the meridian, that means the course is same with a constant course, I can draw the course continuously, and you will see that when I draw that course, it will become a spiral and it will finally end up in the North Pole. So this spiral is called the rumb line. Okay. So rumb line means basically in a Mercator chart, your course is a rumb line because it will be intersecting the meridians in the same constant course or same constant angle, right? So once you take it into the spheroidal earth, what will happen is that this course, not unlike a great circle, these courses will be cutting the meridian in the same angle, right? And it will become a spiral and it will converge on the North Pole. Are we clear? Right. So those are rumb lines, right? So in a Mercator chart, rumb lines are straight lines basically. Let's go back to. So what are the advantages of Mercator chart? I'm sure if you want to take a screenshot or something, take the screenshot, right? you have to compare the advantages and disadvantages. Maybe in your exam also you will get a question like this. Compare the advantages and disadvantages of Mercator projection, right? Number one is that rumbline courses are easily laid out as straight lines. So rumbline courses are straight lines. That is the first advantage. Second advantage, distances are easily measured as scale of distance scale in latitude. That means you can easily use the latitude scale on your side. 1 minute of latitude is equals to 1 nautical mile. You can straight away use the latitude scale to measure the distances. Shapes of land masses in the neighborhood of a point are correctly shown. Don't worry about this one at this point, right? Fourth point is angles between rumblines are unaltered between the Earth and the chart. Angles between the rumblines are unaltered between the Earth and the chart. So that means, for example, you are sailing in the Earth, in the spheroidal Earth, you are taking your ship, right? When you set a course, let's say 045 degrees true, when you go in this course, you are going in the actual Earth. But if you put your position in your chart, and if you continue to put your positions in your chart, you will see that the same angle you are maintaining in the chart as well, 045 degrees, right? So that is the meaning of point number 4. The angles between the gum lines are unaltered between, that means it is same in the Earth and in the chart. Directions remain correct, though distortions of areas occur. So for navigator, what are the main 3 requirements or the main 3 pillars required? Your course, your distance, and your position. So as long as your course is remaining correct, even though the chart is distorting the lands, it's not a problem for you as a navigator. Okay. So number 6 point, directions and the position lines can be transferred correctly from one part of the chart to another part as parallel lines. Okay. This facility, which is often used by navigator for obtaining running fixes, is not available in most other projection. You can easily do running fixes in this chart without a problem because you can transfer your courses into another part of the chart. That is what it says. Okay, right. So what are the disadvantages? Disadvantage is that great circles cannot be laid off in the Mercator chart because they will appear as curved courses. They are not going to be straight lines. Great circles. Then number 2, polar regions cannot be represented due to extreme large distortions. So as I explained earlier, if you can remember, when you go into northern or southern latitudes, further north or south, right, the distortion is very high, where you will not be able to represent the land or the sea. So you cannot basically use Mercator charts beyond certain north or south latitudes. Are we clear? Are we clear, guys? Cool. කට්ටිය නිදිද?
Yes, sir. Yes.
Oh, you're sleeping. That means you said yes. Okay, the scale of distance, which is the scale of latitude, is a varying unit. That is the next problem. What does this mean? This you should understand clearly. For an example, let me go back. Okay, let me finish the point number 4 as well. Areas cannot be compared due to the varying distortions. That you understand. For example, Greenland in a Mercator chart will be bigger than Africa, but in reality, Greenland is not. Right? But you have to understand this third point very clearly, because when you are doing chart work, this matters, right? When you are measuring a distance in chart, this matters. Now assume that you have a waypoint between here and here. Okay. Are we clear, guys? Okay, let
Yes, sir.
me draw a line. Okay, let's say you have a course between these 2 points. Assume that this is a straight line, okay? Okay, let's use the rule. Okay. Okay, can you see this?
Yes, sir.
Okay, so let's assume that you have now when you are measuring the distance between these two courses, these two waypoints, okay? How you normally do? You take the divider and you go into the latitude side, and by using the divider you take the distance in the latitude scale and you measure it, isn't it?
Yes.
මම
Yes, sir.
මේක සිංහලෙන් කියන්නම්. දැන් ඔයගොල්ලෝ මේ මෙතන මේ වේ පොයින්ට් එකේ ඉඳලා මේ උඩ තියෙන වේ පොයින්ට් එකට ඩිස්ටන්ස් එක මෙෂර් කරද්දී ඔයගොල්ලෝ මොකද්ද කරන්නේ? ඩිවයිඩර් එක අරගෙන මේ සයිඩ් එකේ ලැටිටියුඩ් එකේ සයිඩ් එකට ගිහලා ඩිවයිඩර් එකෙන් මැනලා මයින්නවා ඩිස්ටන්ස් එක. ඒකනේ ඔයගොල්ලෝ කරන්නේ. හැබැයි ප්‍රශ්නයක් තියෙනවා, පේනවද? මේ පේනවද ලැටිටියුඩ් ස්කේල් එක ඈත් වෙනවා. ලැටිටියුඩ් ස්කේල් එක ඈත් වෙද්දී ඔයගොල්ලෝ මයින ඩිස්ටන්ස් එක ඇකියුරේට්ලි එන්නේ නැහැ. උදාහරණයකට මෙතනින් ඔයා ඩිස්ටන්ස් මැන්නොත් මේ පෙන්වන්නේ 60 degrees to 50 degrees means that is 10 dlat, 10 degrees dlat, 10 degrees dlat is 600 nautical miles පෙන්වන්නේ මේ divider එක මෙතන ඉඳලා මෙතනට තිබ්බොත් 50 ඉඳලා 60 වලට තිබ්බොත් this is 600 nautical miles. But if you take the same divider and keep it between 70 and 60, again dlat is 10 degrees, but again the distance is 600 nautical miles. But can you see, if you take the distance between 60 and 70, or 50 and 60, and if you measure the distance between these two waypoints, the distance that you measure by using which is going to be the correct one, between 50-60 or 60-70? Can you see there is a error based on the latitude scale? එතන error එක දැක්කද? උගන්න පේනවද එතන error එකක් එනවයි කියලා? ඕකේ. අන්න ඒක නිසා
Oh,
තමයි
sir.
ඔයගොල්ලෝ කෝස් එකක ඩිස්ටන්ස් මනිද්දී අනිවාර්යෙන් මේ වේ පොයින්ට් දෙකේ මැද්දෙන් මයින්ඩ්. ඩිවයිඩර් එක ගන්න, ඩිවයිඩර් එක අරගෙන measure it in the middle. මේ උඩින් ගන්නත් එපා ඩිස්ටන්ස් එක. මේ යටින් ගන්නත් එපා ඩිස්ටන්ස් එක. average mean මේ latitude එකේ නැත්නම් middle latitude එක තමයි හරිම එක. mean latitude එකෙන් තමයි ඕගොල්ලෝ ඩිස්ටන්ස් මෙෂර් කරන්න ඩිවයිඩර් එක තියන්න ඕනේ. නැතු උඩින් තියන්නත් එපා, යටින් තියන්නත් එපා. මැද්දෙන් තමයි තියන්න ඕනේ ඩිවයිඩර් එක. අන්න එතකොට තමයි ඔයගොල්ලන්ට ඩිස්ටන්ස් chart එකේ හරියට මෙෂර් කරගන්න, හරියට නෙමෙයි approximately corrected distance එක මෙෂර් කරගන්න පුළුවන් එතකොට. මම මේක සිංහලෙන් කිව්වේ ඔයගොල්ලන්ට තේරුණාද මං කිව්වේ?
ඔව් සර්.
Oh, sir.
Thank you.
හරි. ඒක වෙන්න හේතුවක් දැන් තේරෙනවනේ. ඇයි එහෙම උනේ කියලත්. Alright, okay. That's why I wanted to do some chart work with you guys, because I'm sure you will pass your exam, but that does not mean that you know navigation, right? Anyway, so now let's
look on to the Mercator projection natural scale, right? So in the chart, I'm sure you will see the scale of the chart, especially even in EGDs, even in electronic navigational charts, or even in paper charts, you will see a scale, right? ඔගොල්ලෝ අහලා ඇති සිංහලෙන් ඔගොල්ලෝ ඉගෙන ගන්න කාලේ 1/20 chart, 1/50 chart එහෙම scale එකක් දැකලා ඇතිනේ නේ. Isn't it?
ඔව් සර්.
So in nautical charts also you have a natural scale. Okay, I'm sure you have I mean, if somebody is having a chart, try to I don't have a chart with me. If you have a chart, right, try to take a image of the chart scale, and please put it in the group so that I can take it and show it here. කාගේ ගාව හරි chart එකක් මේ වෙලාවේ තියෙනවා නම් scale එක පොඩ්ඩක් photo එකක් අරගෙන දාන්න group එකේ. මම ඒක මෙතනට අරගෙන පෙන්නන්නම් because I don't have a chart with me, right? Anyway, the natural scale. The natural scale of a chart is the ratio that the distance between 2 points on the chart bears the actual distance between them on the earth. Natural scale is normally expressed as the relationship that 1 minute of longitude, 1 minute of longitude, okay, uh, 1 minute of longitude, shit, 1 minute guys, okay. The natural scale is normally expressed as the relationship that 1 minute of longitude on chart bears to 1 minute of longitude on earth in that latitude. Okay, ඒක තමයි මේ natural scale එක ඇටියට define වෙන්නේ. ඒ කියන්නේ මොකද්ද මේකේ තේරුම? Did anybody manage to put this one?
Yes sir.
Okay, okay.
It is in group.
Give me a minute. Give me a minute. Okay. Okay. See here, you can see the scale 1 to 500,000. Can you see it here? At latitude 55 degrees. Can you see it? Can you see it, guys?
Yes, sir.
පේනවද මේ මෙතන chart එකේ පෙන්නලා තියෙනවා පැහැදිලිව? Somebody joined? Okay. chart එකේ දැන් මෙතන පෙන්නලා තියෙනවා එකට 500,000 at latitude 55 එකක් කියනවා. එතකොට දැන් ඔයගන්න මෙතන පේනවා 48 degrees තමයි latitude එක මේ chart එකේ තියෙන්නේ. 49 degrees තමයි latitude එක chart එකේ තියෙන්නේ. 55 එකක් ගැන තමයි මෙතන කතා කරලා තියෙන්නේ. Can you understand that? මම මේ කිව්ව එක තේරුණාද?
නෑ සර් මේ තේරුණා.
Okay. Don't, I mean, we have not fully covered it yet, right? Just look at it only first. Okay. The scale is 1 to 500,000. That is the scale. And at latitude 55 degrees. Okay. But in the chart, you cannot see 55 degrees. What you can see is 48 degrees, 49 degrees. I'm sure when you go up, 50 degrees will be there, 52 or maximum 52 degrees. But you will not see 55 degrees in this chart. But it says 1 to 500,000 at latitude 55 degrees. Okay, just keep this in mind. මේක පොඩ්ඩක් දැනට ඔළුවේ තියාගන්න. අපි මෙතනට පස්සේ එමු මොකද්ද මේ උනේ කියලා බලන්න. Okay. Okay. Right. So the natural scale is normally expressed as the relationship that 1 minute of longitude on a chart, 1 minute of longitude on a chart bears to be 1 minute of longitude on the earth in that latitude. In that latitude කියන එක තමයි මෙතන දැන් the most important part is in that latitude. But in simple, natural scale is equal to chart distance divided by earth distance. Okay, are you clear? Right? Just remember this one. Natural scale equals to chart distance divided by earth distance. ඔන්නෝක පොඩ්ඩක් මතක තියාගන්න. What is that? Chart distance divided by earth distance in that latitude. Okay, are we clear?
Okay, sir.
Right. So let's try to work out to see if 1 minute of longitude, if 1 minute of longitude on a chart is represented by 5 millimeter in latitude 60, what will be the natural scale in that latitude? Okay, right. Again, මම මේක සිංහලෙන් කියන්න මේක පොඩ්ඩක් පැටගෙන හින්දා මේක සිංහලෙන් කියන්නම් නැත්නම් ඕගන්ට මේ පොඩ්ඩක් තේරුම් ගන්න අමාරු වෙනවා මේක right කීප දෙනෙක් මේක තිනවා මේ chart එක thank you right so මොකද්ද මේ කියන්නේ කියන එක පොඩ්ඩක් ආපහු අපි පොඩ්ඩක් නෙමෙයි හොඳටම තේරුම් ගන්න ඕන පාර්ට් එකක් මේක මොකද ගොඩක් කට්ටිය කටපාඩම් මේවට උත්තර කියන්නේ without any understanding what it is. Alright, okay. So you cannot see my writing pad here. Can you all see what I'm writing?
Yes, I can see.
Yes, sir.
Okay, now natural scale means what? පොඩ්ඩක් ලස්සනට ලියමු නේද? Okay, the natural scale is chart distance divided by earth distance. Okay, right. Now let's assume that if the chart distance here in the previous example, if 1 minute of longitude is chart of a on a chart is represented by 5 millimeter in latitude 60, the natural scale in that latitude would be, what would be the natural scale? Okay, somebody joined. Okay, anybody is having somebody have raised the hand. Minura PML, do you have a question? Minuka PML, question එකක් තියෙනවද?
Yes, sir. I want to know what is the earth distance.
හරි ඒක තමයි කියන්න යන්නේ මිනුක මේ just I'm going to explain what that is, okay?
Okay, sir. Thank you.
Alright, okay. Now, what is the question? If 1 minute of longitude on a chart is represented by 5 millimeter in latitude 60, the natural scale in that latitude. Okay, so let me write down the question first. If 1 minute of longitude in a Mercator chart is equals to 5 millimeter at latitude 60 degrees, what is the natural scale? So, sorry. What is the natural scale? Uh, Guys, can you give me a minute? I will drink some water and come. Can you give me a minute?
Okay, sir.
Give me a minute. Hold on. I'm still not fully recovered. All right. Can you hear me?
Yes, sir.
Okay, this is bit complex, but so I hope everybody put your focus into this one. Make a product complex කතාවක්. ඒකින්ද product focus එක I will explain both in English as well as in Sinhala as well, okay? So, what does it mean? If I draw the earth, okay, assume that this is the wait. Okay, if this is the equator, so this is 60 degrees. Okay, so if we take one piece, assume that this piece is 1 minute of long 1 minute. Okay, don't mix up. This is 1 minute of longitude. Are we clear?
Yes, sir.
Yes, sir.
Okay, this is 1 minute of longitude. Okay, so if this is 1 minute of longitude, this is not 1 degree. Okay, it is 1 minute. Don't mix up, huh? Right? And if I draw the Mercator chart at 60 degrees, let's say this is 60 degrees and this is the Mercator chart. So in the Mercator chart, this 1 minute is shown as this 1 minute is 5. This is 1 minute, okay? This is 1 minute, which is equals to 5 millimeters. Are we clear?
Yes, sir.
Okay, this is 5 millimeter. Okay, right. So what we have to find out here is that the as per the natural scale, chart distance needs to be divided by the distance at that latitude. Okay, at that latitude, right? So here you can see chart distance is 5 millimeter. Okay, but how to find out the Earth distance? That means the actual nautical mile distance here. What do you call it? The actual nautical mile distance at this point. What do you call it? The actual.
Departure.
What is that? Sorry.
Departure.
De-
Departure. Yes, exactly. Departure of 1 minute at 60 knot. So from parasailing formula, if we know d long of 1 minute, distance in nautical miles, we can very easily find out the distance in nautical miles at 60 degrees north. You know that departure divided by d long is equals to what? What departure divided by d long is what? Somebody tell me as per the parasailing formula.
Coastland.
Ah, very good. Cos latitude. Okay. So if we know the distance of d long, we can very easily find out departure. So the distance of d long, how much is the distance in meters of 1 minute longitude in the equator? Equator එකේ 1 minute longitude equator එකේ 1 minute longitude එකක distance එක මට කවුරු හරි මීටර් වලින් කියන්න පුළුවන්ද? කොහොමද equator එකේ distance එක equator හොයාගන්නේ? Okay, let's see. Since we don't have much time, I will do it by myself. So from the formula, you can see distance in the equator, for example, latitude is what? In the equator, what is the latitude?
0.
0. So departure divided by d long in the equator cos 0 degrees, not theta, 0. 0 degrees. Are we clear? So cos 0 is how much? Take your calculator and you can see, you type cos
1.
0
1.
is equals to 1, yes. So in the equator, departure is equals to d long. Can you see that? Okay. So that means the east-west distance is exactly d long, right? So 1 degree, sorry, 1 minute of d long is how much? How many meters? How many meters, guys? 1 minute of d long. 1 minute of d long is how many minutes? How many meters? How many? Talk. You can see 1 minute of d long.
005.
How much? දැන් මේක මම සිංහලෙන් කියන්නම්. d long දැන් මෙතන පේනවාද departure කියන්නේ east west distance එක. right? D long සහ departure සමාන වෙනවා. ඒ කියන්නේ කෙරීම අපිට D long number of D longs ගන්න පුළුවන් departure එක හැටියට. ඒ කියන්නේ departure එක කියන්නේ distance එකක්නේ. එතකොට D long 1 minute equator එකේදී D lat 1 minute එකක් ගත්තොත් එහෙම ඒක සමාන කෙරීම සමාන වෙනවා D long ට. right? එතකොට D lat 1 minute එකක් කියන්නේ එක nautical mile එකයි. එතකොට D long 1 minute එකට ඒක කෙරීම සමාන වෙනවා. එතකොට එක nautical mile එකක් කියන්නේ කීයද?
1852 meter.
1852 because this is the standard, okay? Right? So you can see 1 minute of D long in the equator is 1852. ඒක පැහැදිලිද? Right. So then, right, if we wanted to find out how many millimeters this one, because our longitude scale is given in millimeters. එහෙමනම් මේක millimeters කරගන්නේ කොහොමද දැන්? D long 1 minute එකක දුර millimeters වලින් කීයද? equator එකේදී 1852 centimeter කරගන්න නම් කීයෙන් වැඩි කරන්න ඕනේ? Meters, centimeters කරන්න. Then this is meters, no? So if you want to
100
make it centimeters, you have to make it multiplied by 100, and centimeters to
by
millimeters, you
10.
have to multiply it by 10.
10.
So 8552 into 1000. Isn't it? Are we
Yes,
clear?
sir. Yes, sir.
So now we have found out how much is this one. This is 1852 into 1000. Then we can easily find out how many millimeters in 60 degrees north between 1 minute of D long. You can simply go back to departure divided by D long is equals to cos latitude. So departure we need to find out in millimeters. So D long in millimeters is 1852 into 1000, and cos 60 degrees. Cos 60 is how much?
0.5.
Yeah, half. Okay, 0.5. So it's basically half of the uh, uh, departure at what do you call it? The at the equator. So now, so this is the actual meters distance in 60 degrees north between in 60 degrees north. This is the actual distance in millimeters. Okay, in millimeters between d long of 1 minute. This is the earth distance. This is the actual earth distance. Are we clear now?
Yes, sir.
Okay. So as per the natural scale formula, what is the natural scale formula? Natural scale formula is equals to 1 minute chart distance divided by 1 minute earth distance at 60 degrees. So that means natural scale is equals to chart distance divided by earth distance. So we took 1 minute of 60 degrees and we took 1 minute at 1 minute in chart. Sorry, 1 minute in chart. which is equals to, and this is 1 minute in Earth at 60, okay, which is equals to 1 minute in chart is how many millimeters? 5 millimeters.
5 millimeters.
5 millimeters. And 1 minute of Earth at 60 is how many? 1852 into 1000 into 0.5. Can somebody do the calculation and find out? It is going to be 1 divided by how much? You divide this one by 5, then you get the answer. Can somebody tell me the scale? Can somebody tell me the scale of this chart? Somebody type the answer?
1,85,200 sir.
Yes.
A
So the
cat
scale of this
1,85,200.
chart is 185, 200. This is a scale. Are we clear? Then තේරුණාද? Okay, now if you go to this chart, let me take this chart. If you go to this chart, you can see 1 to 500,000. Okay. Can you see this chart, guys? Okay, what does that mean? Now here you can see 1 minute is almost like I don't know how many millimeters. Okay. I don't know how many millimeters, right? 1 minute of longitude, you can take your divider and measure how many millimeters this is in your chart. And if you multiply that millimeters by 500,000, you will get, let's say, between let's say you want to find out the actual distance between Rouen and Seine. This is Seine River in France. Let's say you want to find out the distance between Rouen and here, for example, between 2 points. What you have to do is you measure using the divider the distance in millimeters, right? By using the natural scale, multiply that millimeters by 500,000, you will get how many millimeters between these 2 points. Are we clear? Yeah, so basically that is natural scale. So by using, so this scale, why it is given at 55 degrees, now I think you can understand why it is given at 55 degrees. Even though the chart is made for 48 and 49, let's see how this Mercator chart is uh, produced. So you need a reference latitude for any Mercator chart. So this is the reference latitude. Like 60 degrees in my previous example, you need a reference latitude. Are we clear?
Yes, sir.
All right, now it's almost 10 o'clock. but I wanted to complete Mercator chart construction. What do we do? Do you want me to continue or do you want me to stop? පොඩ්ඩක් කියන්න එක්කෙනෙක් දෙන්නෙක් මොකද කරන්න කියලා අපි කන්ටිනියු කරනවද තව විනාඩි 10ක් විතර නැත්නම් මෙතනින් නවත්තනවද
Sir, continue.
මොකද
Sir, continue කරමු. ඊටුට ඉවර කරමු sir.
alright so let's go to the Mercator chart construction දැන් Mercator chart එකක් හදන්නේ කොහොමද කියලා පොඩ්ඩක් බලමු reference latitude එකක් දුන්නාට පස්සේ for example let's construct a Mercator chart in area chart area 28 degrees north to 32 degrees north 15 west to 20 west to a natural scale of 1 to 1 million in latitude 30 degrees north. So reference latitude එක 30 degrees north. Natural scale is 1 to 1 million. Your base latitude is 28 and the top latitude is 32. But now we need to create a chart, right? To this natural scale. So since the natural scale is given, we need to find out the distance of D long at 30 degrees north. Okay. So we need to find out the distance of uh, uh, D long at 30 degrees north. So let's write down the question. I will write down the question here so that if you want to take a screenshot, you can take a screenshot now because I'm going to construct a Mercator chart. Shall I proceed? All right. Okay. So the chart is required between uh, so the chart is required between 20 degrees north to 32 degrees north, 15 degrees west to 20 degrees west. So okay, forget about these two. This is not that important. What is important in these two? And the reference latitude is 30 degrees north. Natural scale is 1 to 1 million. Okay, so 1 to 1 million. Right? From this, we can easily find out at 30 degrees north what would be the Earth actual distance is. Okay, right. So let's write down the let's find out the longitude. Sorry, the D long 1 minute distance in 30 degrees north. Okay, right. So this is equals to cos 30 degrees. Right? Are we clear, guys? Okay, so in the equator, we saw that previously 1 minute of D long is equals to 1852 into 1000 to convert into millimeters. So 1 minute of departure at 30 degrees 1 minute of departure at 1 minute of departure at 30 degrees is 1852 into 1000 into cos 30 degrees. Are we clear? So we can easily find out that at 30 degrees, okay, 1 minute of d long is equals to this amount, right? So the actual distance of 1 minute of longitude is this, okay? So let's see how much it is. Can you use your calculators and find out how much it is? Yeah, 160387.9.05, right? Millimeters. Are we clear? So this is, let's see what this is. This is in 30 degrees, 1 minute of longitude. In 30 degrees, 1 minute of longitude d long, okay? 1 minute of, not longitude d long, 1 minute of d long is this amount at 30 degrees north. So what is the natural scale? Natural scale equals to natural scale is equals to chart distance divided by Earth distance at that latitude. So the chart distance, we need to find out what will be our chart distance, right? Because Earth distance we already know, and the natural scale already know. Now we need to find out what would be the chart distance of 1 minute of d long at 30 degrees. So we know our natural scale is already given, that is 1 to 1 million, which is equals to chart distance of 1 minute d long at 30 degrees divided by 1603,879 decimal 05. So I would just simply write chart distance is equals to 1603,879 decimal 05, right, divided by 1 million. And that is going to be how much, guys? 1 million. 1, 2, 3, 4, 5, 6. How much you are getting? 1.6 millimeters. Are we clear? Am I right?
Yes, sir.
Harinder? Harinder?
Yes, sir.
Hari.
Okay. So that means what? දැන් ඔය 1.6 1.6 millimeters කියන්නේ මොකද්ද? Simple. දැන් chart එකේ ඔයගලන්ට chart එකේ base 28 degrees එකක් ගහගත්තොත් now here this is 28 degrees. Now you know the length between 1 minute of D long, which is 1.6 millimeters. If you want to know let's say this is 0 degrees, this is 1 minute. So if you want to know what is 1 degree, the distance between here to here, how many centimeters or millimeters, easily now you can find out because you already know 1 minute is 1.6 millimeters. Then how much would be 60 minutes? That is 96 millimeters, isn't it?
Yes, sir.
So now you can easily find out 2 degrees where is 2 degrees, 3 degrees where is. Now the next problem, now 28 degrees, okay. Now you have to create the chart now. You have to go up, isn't it? Now we have already found out the base of the chart. Now we need to create the chart top. You have to go upwards because you are going into 32 degrees north. So you have to go up. Are we clear? All right. Okay. So now, now we need to create the now we need to find out where is 29 degrees. At what distance 29 degrees is going to lie. Then 30, where is 30? And where is 31? Likewise, we can go upwards. So we need to find out where is 29 degrees. Okay. But the definition of the meridional paths, what it says? What is the definition of meridional path? Let me bring back the slide. මේක සමහර විට සමහර කට්ටියට තේරුම් ගන්න ටිකක් අමාරු ඇති, but that's okay. Okay, you are not going to make Mercator charts now, so don't worry about that. But I hope most of you can understand what I said. Okay, can you see difference of meridional bar? Can you see this?
Yes, sir.
Okay, so DMP between two latitudes is the length of a meridian between those latitudes on the Mercator chart, expressed in units of longitude scale. Expressed in units of longitude scale. Okay, so what we need is now we have to easily find out the DMP between 28 and 29. Difference of meridional paths of 28 and 29. So let's go back to the meridional paths. This meridional path. I think I showed you that. Yeah, it's here. So what is 29? The 29 is here. Okay. So 28 is, you can see here it is, let me write down. MP of 28 is 1740 decimal 18. MP of 29 is 1808 decimal 09. All right. So I just basically wrote down these two, and can you see? MP of 28 is this one. MP of 29 is this one. Can you see that, guys?
Yes, sir.
ඕකේ. දැන් මේ මොකද්ද මේක ඉටියන පාට් කිව්වේ ආපහු මතක් කරගන්න. ලොන්ජිටියුඩ් එකේ දිග අරගෙන ඒක ඉක්වේටර් එක දිගේ තිබ්බම රයිට් එච්චර උසකින් තමයි 28 තියෙන්නේ. මර්කේටර් chart එකේ. 29 තියෙන්නේ 1800 ලොන්ජිටියුඩ් එකේ කෑලි 1808ක් උඩින්. 28 තියෙන්නේ ලොන්ජිටියුඩ් කෑලි 1740ක් උඩින්. ඔන්න ඕක තමයි මේ සිම්පල් විදියට කිව්වොත් කියන්න පුළුවන්. ඕකේ. එහෙනම් 28 සහ 29 අතර between 28 and 29 how many parts are there? You have to subtract and see DMP between these two. So how much is that one?
67.91.
67.91. Okay. Okay, 67.91. That means what? In simple, now we know this is 1.6 millimeter 1 minute. 1.6 millimeter. So 1.6 millimeter ඒවා තියෙනවා මෙතන 28 ඉඳලා 29ට වෙනකන් 67.91. ඕක තමයි ඔය කියන්නේ. Okay. So 1.6 ඒවා 67.91 මෙතනට ගැහුවම මේ උස එනවා ටක් ගාලා. So how much is the length between 28 degrees and 29 degrees? You have to multiply 1.6 by 67.91. So that is how much?
එකසිය අටයි දශම පහයි හය පහයි
100.
අටයි දශම හය පහයි.
Alright. Okay. One minute. 1.6 into 67.91 is yes 108.65. Okay. So how many from 28, how many millimeters are there to 29? 108.6 millimeters are there up to 29. Are we clear?
Yes, sir.
Now you can very easily mark where is 29 is. Then you divide the 29 into 60 equal parts. Then you will get the minutes in between. So likewise, you have to find out between 29 and 30 what is the DMP. Using that DMP, you can find out from 29 up to 30 what is the length in millimeters. Apply that one and find out where 30 is. Likewise, you can go upwards. This is how the Mercator chart is getting developed. Are we clear, guys?
Yes, sir.
Right? So this is 108.6. So in that case, in a Mercator chart, we can easily derive a formula. This is one waypoint, this is another waypoint, this is a Mercator chart. Okay. This is the second waypoint, and this is going to be the course. And you can see this is D long scale. Why? This is one longitude, this is another longitude. But this actual distance is what? This actual distance is coming in millimeters or something. This actual distance is D long scale. Isn't it? What is this actual distance, guys? How many let's say this is D long is like 3 degrees between here to here. So the actual distance of this 3 degrees is, we'll convert into minutes, and 1.6 millimeters. Isn't it? Previous chart. Are we clear?
Yes, sir.
Okay. Then what is this height? This height is what? dmp multiplied by d long scale. D long scale again is 1.6. Isn't it? This is the actual height now in millimeters. Isn't it?
Yes, sir.
Course, සද්දයක් නෑනේ. Are
Yes,
we
sir.
clear? You are following or any questions? Are we good, guys?
Yes, sir. Yes.
All right, okay. I can hear some music as well. Right, so you can see this, if this is the course, this is the course, right? Equal angles, right? These are parallel. So now from this triangle, you can see tan cos equals to, this is d long. This length is 3 degrees into 60 into 1.6. I would say this is d long, right? In minute scale, divided by this height is dmp into 1.6. Now you can see we don't need the longitude scale. We don't need that because automatically it will cancel and you will get your answer as tan cos equals to d long in minutes divided by dmp. So this is Mercator sailing formula. Are we clear?
Yes, sir.
දැන් මම ෂුවර් එකටම දන්නවා ඔයගොල්ලෝ Mercator sailing කරලා තියෙන්නේ. මේ ෆෝමියුලා එක යූස් කරාද නැද්ද?
use කරා sir.
එතකොට දැන් තේරුණාද මේක ආවේ කොහොමද? මේක ඇයි මෙහෙම යූස් වුනේ? මේක දැන් මේකේ පොඩ්ඩක් යම් දහක් තුනකට පැහැදිලිතාවයක් ආවද?
ඔව් sir. මේ ඇත්තටම අපි sir මේ ෆෝමියුලා එක දාලා ගාන හදපු එක තමයි කරේ. ඔක ආපු ක්‍රමේ නම් අපිට මේ දැනගන්න හම්බුනේ නැහැ. දැන් නම් ඉතින් ඇත්තටම මේ ඔක්කොම තේරුනේ නැහැ. නමුත් ඉතින් යම් කිසි යම් තාක් දුරකට තේරුණා මොකද වෙන්නේ කියලා.
ඔක්කොම තේරුම් ගන්න you have to listen back again. ඔගොල්ලෝ මෙතනට දානවා d long. ඒක දානවා dmp. මෙහෙමනේ ඔයගොල්ලෝ ගාන හදන්නේ. එහෙම නේද?
ඔව් sir.
ඔව් සර්.
මෙතනට දාගන්නවා dlat. මෙතනට දාගන්නවා distance. දැන් දාගන්නවා departure. ඔන්න ඔම එකක්නේ. මේ සුබ්‍රමාණියම්ගේ වැඩක් මේක. මේක පැටගෙනවා මේ විදිහට කරාම ඇත්තටම. I'm not blaming him. When you're doing it, you have to do it in two triangles. Right? You take this one as d long. You take this one as dmp. But I'm sure some of you may have understood what I did. But if you want a thorough understanding, you have to go back again. I will put the recording, right? Then once you hear it time to time. So these are the two triangles merged together. But I recommend that you keep it in two different triangles. Here. Okay. But when we are doing the Mercator sailing sums, in the next session we will do the sums, then you will understand why I am telling you this. Are we clear? Alright.
ඔව් සර්.
Yes, sir.
Okay. Then මේ ඩෙරිවේෂන් එක අඩු ගන්න මේක මෙහෙම වුණා පොඩ්ඩක් හරි තේකිච්ච කට්ටිය ඉන්නවද මෙතන නැත්නම් එහෙම පිටිම තේකුන්නේ නැද්ද?
Understood, sir.
තේරුණා සර්.
මොකද මේ මම ඊට පස්සේ next session වගේ ඉඳලා වැඩි deep යන්න නැතුව එහෙම කරන්නම් එහෙම වුණොත් එහෙම so I need your feedback guys. මට ඔයගොල්ලන්ගේ feedback එක පොඩ්ඩක් දෙන්න
මෙහෙම
මම
හොඳයි සර්. ඒකට මේ
I will stop.
මෙහෙම හොඳයි සර් අපිට එතකොට.
Yeah, give me a minute. I will stop the recording.